Graphical method of solving linear programming problems. Now, let us graph the constraints stated as linear inequalities in our example. The graph of this system consists of the points common to all off-planes determined by the inequalities 5x plus y less than or equal to 100, x plus y less than or equal to 60, x greater than or equal to 0 and y greater than or equal to 0. Each point in this region represents a feasible choice open to the dealer for investing in tables and chairs. The region therefore is called the feasible region for the problem. Every point of this region is called a feasible solution to the problem. The region other than feasible region is called an infeasible region. Therefore, the points 10, 50, 0, 60, 20, 0, etc. are the feasible solution for the problem. Any point outside the feasible region is called an infeasible solution. For example, the point 25, 40 is an infeasible solution of the problem. Optimal solution. Any point in the feasible region that gives the optimal value, that is, either maximum or minimum of the objective function, is called an optimal solution. Now, we can see that every point in the feasible region satisfies all the constraints given in the four equations, and since there are infinitely many points. Therefore, with the help of fundamental theorems in linear programming problems, we can find out the optimal solution. Theorem 1. Let R be the feasible region for a linear programming problem, and let Z is equal to ax plus by be the objective function when z has an optimal value, that is maximum or minimum, where the variables x and y are subject to constraints described by linear inequalities. This optimal value must occur at a corner point of the feasible region. Theorem 2. Let R be the feasible region for a linear programming problem, and let z is equal to ax plus by be the objective function. If R is bounded, then the objective function z has both a maximum and minimum value on R, and each of these occurs at a corner point of R. If R is unbounded, then a maximum or minimum value of the objective function may not exist. Therefore, in the example what we are discussing, the corner points of the bounded region are O 0, 0, A 20, 0, B 10, 50 and C 0, 60. Now, let us compute the corresponding Z value at these points. At 0, 0, the value of Z is 0 rupees. At A 20, 0, the value of Z is 5000 rupees. At B 10, 50, it is 6250 rupees. At C 0, 60, it is 4500 rupees. We observe that the maximum profit to the dealer results from the investment strategy 10, 50, that is buying 10 tables and 50 chairs.